Aloha, my name is Anthony Christie, and I'm in the Computer Science Department at the University of Hawaii at Manoa. What we have here today is the KiP software component of the KiP project. The KiP project is meant to be an educational AMI system for the smart grid. This screencast specifically focuses on the KiP software. The KiP software is the component of the project that communicates with the KiP board. The KiP board is able to take power measurements and then store those power measurements in UDP packets, which are then sent to the KiP software for analysis. The KiP software allows us to analyze the power measurements in real time and also store those power measurements for later view using our Packet Explorer. The KiP software also comes with several other tools. It allows us to configure the board through basic menus, and this allows us to use the KiP software also as a deployment strategy. That is, if we have multiple boards, we can set the IP addresses, the MAC addresses, and the other board settings separately for each individual board. The KiP software also has a configuration file that you can find out about on our wiki that allows you to configure the KiP software to suit your personal needs. You can change how often the real-time panels update. You can change other various settings such as default IP addresses, ports, hertz, etc. So let's go ahead and take a look at the KiP software. Right now, the first thing that we have here is the control panel. And in the control panel, this allows us to determine which board we are talking to, on which port, how often we are going to pull that board, and also the duration that we're going to pull the board for. So in this case, I'm simply going to run our software using the emulator, and the emulator is running on the local machine. So let's go ahead and set the address to the local host. And the emulator is also running on port 4445. So the next field that we have is the hertz field. And you can see in the hertz field we have a value of 5. And what that says is that our software is going to then pull the KiP board 5 times per second. And then the final field we have here is the duration field. And this says how long does our software continue to pull the board. So in this case, we would pull the board 5 times for 1 second. If we wanted to pull it longer, we could say maybe we want to pull the boards 5 times for 10 seconds. If you would simply like to continually pull the board, we can simply set this field to -1. And the software will continue to pull the board until we hit the cancel button. So what do we get when we actually pull the board? So the KiP software creates a packet, sends it to the board, and then the board takes whatever power measurements it currently has, puts it back into a UDP packet, and sends it back to the KiP software. The KiP software then takes that packet, analyzes it for things such as voltage, frequency, 2 different current channels, and then can display that data in real time and also store that data to be viewed later. Let's go ahead and take a look. I'm going to go ahead and pull the board emulator for an infinite amount of time until I hit cancel at 5 hertz. So as soon as I hit send triggers, we see a series of status updates in our log window. We can see all of the packets being sent, and we can also see all of the packets being received. It's also possible to get more information out of this debug window by turning on the debug option in the KiP configuration. Let's go ahead and look at what kind of real-time data we're getting. So if we come over to the real-time data window, we can see that the current frequency is about 26 hertz. We can also see the watts and the current. The real-time data buffers up to 20 data points and then updates itself once a second. This gives us a real-time view of the current power that the board is reading. But we also might want to analyze packets that have already happened. So let's go ahead and stop pulling the board, and we'll come over here to the Packet Explorer. The Packet Explorer allows us to view information about individual packets on a very fine-grained scale. If we hit the refresh button, we can start going through and opening up the packet hierarchy. Here's how the packets are stored. They are stored by year, month, day, hour, minute, second, and then finally the packets are stored as their millisecond value. So we can click these packets and we can see the sinusoidal waveforms of the 2 current channels. And any packet we click will allow that to change on the right there. Even more, we can then click this details pad and get many details about individual packets, such as the frequency, such as the current, and the amps and the watts. We can also go through and view individual DAC measurements, and these DAC measurements are the actual power measurements that the board sent the software. This is useful because it's useful in debugging, and you also might want to have fine-grained control over what exactly you're getting in those measurements, so we can look at all of that. Finally, we can use this software to set a bunch of configuration options on the board itself. For instance, we might want to set the board's ID, the IP, the MAC address, or the delay. We need to remember that setting the board delay is different than the hertz in this software. The hertz in the KiP software simply says how many times per second do we want to send a trigger packet to the board requesting data. However, the set delay option under the board configuration menu says how many times per second should the board sample the power readings to get power data. So let's not get those confused. It's important to remember that the board configuration options simply affect what is happening on the board, and then these configuration options out front here are what actually works with the interface itself. So if we wanted to change the board's ID, IP, or MAC address, we can simply select one of the options and then enter the new ID. So if I wanted to set the board's ID to 5, I'll just do that and click OK. But we also need to remember that the board configuration options will not take effect until after you click Reset Board. That's because once we send it a packet with a new configuration, the board stores that information in its EEPROM, and then it must reset so that it can reload the information from the EEPROM for the changes to take effect. Finally, if you would like to save your packets, you can click File, Save Packets, and it will save all of the packets that you've captured, and you can also go through and reopen those packets at a later date. And then you can also clear your packets. So any packets that we've captured, I can go ahead and click Clear Packets, and it will confirm that you actually want to do that. We'll then go over to the Packet Explorer, hit refresh, and we'll notice that all of our packets are now gone. So this has been a presentation of the KiP software. Hopefully it's been a bit informative. If you have questions, feel free to email any of us contributors, and we would get back to you. Thank you for your time. Mahalo.